Dear students, in the previous class we discussed the topic related to the basics of the coordinate geometry and the formula to find the distance between the 2 points on the Cartesian plane as well as some problems. Just to recall what we studied in the previous class. If x1, y1 and x2, y2 are any 2 points on the Cartesian system or the Cartesian plane. So the points x1, y1 and x2, y2 are the points. So what is the distance between these 2 points? The distance between these 2 points, that is d equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the formula to find the distance between the any 2 points on the Cartesian plane. So this formula is known as the distance formula. So d equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. One more formula, the distance of a point in a plane from the origin. So the coordinates of the origin, that is 0, 0. From the origin, what is the distance? So the formula d equal to square root of x square plus y square. So this is the formula to find the distance from the origin. So that is d equal to square root of x square plus y square. So in this class we are going to solve some more problems related to the distance formula. So let us consider the first example. Find the distance between the points 4, 2 and minus 1, minus 1. So here the 2 coordinate points are given, 4, 2 and minus 1, minus 1. What is the distance? So let us apply the distance formula. So d equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the formula to find the distance between any 2 points on the Cartesian plane or the Cartesian system. So first one 4, 2. So let us consider x1, y1. In general x1, y1 and x2, y2 are the 2 points on the Cartesian system. So 4, 2, that is x1, y1. And minus 1, that is x2, y2. So these are the 2 points on the Cartesian plane. Now find the distance between these 2 points. Now substitute the values. So here x2 minus x1 whole square. So what is the value of x2? Just to compare the value of x2, x1, y1, y2. So here the x2 value is minus 1. So minus 1. Here sign is minus, x1 is 4, their square. So plus y2, so y2 value minus 1, sign minus, so y1 is 2, their square. Now simplify, so equal to square root of minus 1 minus 4. So both integers have minus sign. Now add the integers, so minus 1 minus 4, that is minus 5 whole square plus minus 1 minus 2 whole square, that is minus 3 whole square. Minus 5 whole square, what is the meaning? So minus 5 whole square means minus 5 into minus 5. So minus 5 into minus 5, here minus into minus, that is plus 5 into 5, 25. So what is answer? Equal to square root of minus 5 whole square, that is 25, plus minus 3 whole square. Minus 3 whole square means minus 3 into minus 3. Minus into minus plus 3 into 3, 9. So which is equal to, now add 25 plus 9, that is 34 units. Square root of 34 units. So this is the distance between these 2 points on the Cartesian plane. Next example, find the values of y for which the distance between the points P 2, minus 3 and Q 10, y is 10 units. Understand the question correctly. So find the values of y. So the 2 coordinate points are given. So the 2 coordinate points are 2, minus 3 and 10, y. and their distance also given. So their distance is 10 units. We have to find the values of y. How to find the values of y? By using the distance formula. So here the coordinates point are P 2, minus 3. So this is x1, y1. And the second coordinate point, that is a Q 10, y, that is x2, y2. So the distance given, the distance between these 2 points is 10 units. So distance is denoted as d equal to 10 units by applying the distance formula. So what is the distance formula? D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now substitute the values. So what is the value of d? D equal to 10 and square root of x2 value. Just compare the values of x1, x2, y1, y2. So x2 equal to 10 minus x1 equal to 2, their whole square, plus y2 means y, so sign minus. So what is the value of y1? Y1 is minus 3, so minus 3 their square. Now simplify. 10 is equal to square root of 10 minus 2. 10 minus 2 means 8 square, plus minus into minus. So here minus into minus, that is plus y plus 3 whole square. Now find the value of y. How to find the value of y? Here square root is there. By squaring on both sides. Squaring on both sides. Squaring on both sides. So we get 10 square equal to, but the right hand side, square root of 8 square plus y plus 3 whole square, their square. So we get 8 square plus y plus 3 whole square. Now simplify. 10 square means 100 equal to 8 square is 64 plus y plus 3 whole square. Either you expand y plus 3 whole square. So this is in the form of identity a plus b whole square, or one more method. Now transpose the constant term. 100 plus 64 becomes minus 64 equal to y plus 3 whole square. So 100 minus 64, that is 36 equal to y plus 3 whole square, or y plus 3 whole square equal to 36. So here in the left hand side y plus 3 whole square, but the right hand side, that is 36, a perfect square number. Now taking square root, so we get y plus 3 whole square, that is y plus 3 equal to plus or minus square root of 36. Here the highest power is 2, so therefore y plus 3 equal to plus or minus root 36, or y plus 3 equal to plus or minus square root of 36, that is 6. Now how to find the value of y? So there are two possibilities. One is a plus 6, another one is a minus 6. So y plus 3 equal to plus 6, or y plus 3 equal to minus 6. Now find the value of y. So y equal to 6 plus 3, transpose plus 3 to the right hand side, that is minus 3. So y equal to 6 minus 3, answer y equal to 3. And here y equal to minus 6, transpose plus 3, so plus 3 becomes minus 3, or y equal to minus 6 minus 3, that is minus 9. So this is the values of y. So either value of y is 3, or value of the y equal to minus 9. I think you understood the problem. Find the values of y for which the distance is given. x1, y1 and x2, y, their distance is 10 units for the examination point of view. So this type of the question is important. So you practice this type of the problems. Next we pass on to the example. Do the points 3, 2, minus 2, minus 3 and 2, 3. Form a triangle. So here the points given. Let P 3, 2 and Q minus 2, minus 3 and R 2, 3 are the 3 points. So what is the question given? Do the points, 3 coordinate points are given, 3, 2, minus 2, minus 3, 2, 3, form a triangle. What is the condition? Now apply the distance formula. Suppose the sum of distances between any two points is greater than the third distance, then we say that these 3 points form a triangle. So first we apply the distance formula. So how to apply the distance formula? So distance formula, D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the distance formula. So first find the PQ, distance between PQ, and next QR and then PR. Suppose the sum of any two distances is greater than the third distance, then we say that so these 3 points form a triangle. So first find the distance between PQ. So PQ equal to square root of. So the coordinates of the point P, that is 3, 2 and Q minus 2, minus 3. So let us consider first coordinate x1, y1 and the second coordinate x2, y2. So these are the 2 coordinate points. Now what is the distance? Apply the values of x2, x1 and y1, y2. x2 value is minus 2 minus x1 value, that is 3, their square, plus y2 value minus 3 minus y1 2 whole square. Now simplify, equal to minus 2 minus 3, that is minus 5 whole square, plus minus 3 minus 2, that is also minus 5 whole square. So what is answer? Minus 5 whole square, minus 5 into minus 5, that is square root of 25 plus 25 equal to square root of 50. Square root of 50. So square root 50 is not a perfect square number. So what is the value of root 50? Approximate value of the root 50 is 7.01. So this is the approximate value of the root 50. Find the square root of non-perfect square number by division method. You already studied in your previous class. So root 50, find the square root by division method. So we get 7.01 approximate value. So approximate value is 7.01. So this is the distance between P and Q. Next to find the distance between Q and R. So next distance, that is QR, equal to square root of. So coordinates of the point Q, that is minus 2, minus 3 and R 2, 3. So let us consider the first coordinate x1, y1 and the second coordinate x2, y2. Now substitute the values. So equal to x2 minus x1 whole square, x2 value 2 minus x1 value minus of minus 2 whole square plus y2 value, that is 3 minus of minus 3 whole square. Now simplify, square root of 2 minus into minus, that is plus 2 whole square plus 3 minus into minus, that is also plus 3 whole square. So what is answer? Equal to square root of 2 plus 2, 4 square, that is 16 plus 3 plus 3, that is 6 square, 36. What is answer? Find the sum. 16 plus 36, answer 52. So the distance QR equal to square root of root 52. So what is the approximate value of root 52? Approximate value of the root 52 is 7.21 by division method. So the square root of root 52 is 7.21. So this is the distance between the QR. And next, third distance is a PR. So find the distance between the PR, that is square root of x2 minus x1 whole square. The coordinates of the point P, that is 3, 2, x1, y1, and R 2, 3, that is x2, y2. Now substitute the values. x2 value 2 minus x1 value 3 their square, plus y2 value 3 minus y1 value 2 their square. So equal to square root of 2 minus 3, that is minus 1 whole square, plus 3 minus 2 1 square. So equal to square root of minus 1 whole square, that is 1, plus 1 square 1, equal to square root of 2. So what is the value of the root 2? Approximate value is 1.41 units. So 1.41 units. So this is the distance between PR. What is the question given? Do the points 3, 2, minus 3 and 2, 3 form a triangle. What is the condition? The sum of any two distances is greater than the third distance. Then we say that these 3 points form a triangle. So first find the distance, that is a PQ plus PR. So PQ plus PR. So what is the value of a PQ? So PQ value 7.01 plus PR 1.41. So what is the sum? 7.01 plus 1.41, that is 8.48. The sum of any two distances is greater than the third distance. Which is the third distance? That is a QR, 7.21. So therefore our conclusion, PQ plus PR is greater than QR. So what is the meaning? Sum of any two distances is greater than the third distance. So then our conclusion is P, Q and R. So these points form a triangle. So P, Q, R form a triangle. So what is the condition? Sum of any two distances is greater than the third distances. Then these points form a triangle. I think it is clear. Next example, check whether 5 minus 2, 6, 4 and 7 minus 2 are the vertices of an isosceles triangle. Understand the question correctly. Are the vertices of an isosceles triangle? What is the meaning isosceles triangle? In a triangle, if two sides are equal, then it is known as isosceles triangle. Two sides are equal. So we have to prove in these points, if the two sides are equal, then it is a isosceles triangle. The vertices are isosceles triangle. So let the point A, coordinates of the point A, that is 5 minus 2, and B 6, 4 and C 7 minus 2. So are the vertices of the triangle. Coordinates of the point A 5 minus 2 and coordinates of the point B 6, 4 and C 7 minus 2 are the three vertices. So we have to prove if any two sides are equal in this triangle, so we say that so these points are isosceles triangle. So how to prove this triangle is isosceles triangle? So you have to apply the distance formula. So distance formula, D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now first find the distance between the point A and B, or AB. So distance AB equal to square root of. So the coordinates of the point A, that is 5 minus 2. Let us consider, so this is x1, y1, and the point B 6, 4, that is x2, y2. Then substitute the values. So the value of x2 is 6 minus x1 is 5, their square, plus y2. y2 is 4 minus y1 minus of 2, their square. Now simplify, equal to square root of 6 minus 5 whole square, that is 1 square, plus 4 minus of minus, that is a plus, 4 plus 2, that is a 6 square. So equal to 1 square 1 plus 36 equal to square root of 37 units. So this is the distance between AB, that is square root of 37 units. Next, to find the distance between BC. Distance BC equal to square root of, so the coordinates of the point B 6, 4, that is x1 y1, and C 7, minus 2 x2 y2. Now substitute the values. x2 value 7 minus 6 whole square plus y2 minus 2 minus 4 whole square. Now simplify, equal to square root of 7 minus 6. 7 minus 6 is 1, so 1 square plus minus 2 minus 4. Minus 2 minus 4, that is a minus 6 whole square. Minus 6 whole square means minus 6 whole square. So equal to square root of 1 square 1 plus minus 6 whole square, minus 6 whole square, that is 36. So equal to square root of 37 units. So this is the distance BC. Next, we have to find the distance CA or AC. So distance CA equal to square root of the coordinates of the point C. Coordinates of the point C 7 minus 2, that is x1 y1, and A, coordinates of the point A 5 minus 2 x2 y2, and substitute the values. So substitute the values. x2 minus x1 5 minus 7 whole square plus y2 minus y1 whole square minus 2 minus of minus 2 whole square. So equal to square root of 5 minus 7, that is minus 2 whole square plus minus 2 minus of minus plus 2 whole square. So equal to square root of minus 2 whole square, minus 2 into minus 2, that is 4, plus minus 2 plus 2, that is 0, equal to square root of 4 equal to 2 units. So this is the distance. Are the vertices of an isosceles triangle? What is the meaning isosceles triangle? If the two sides are equal, that is isosceles triangle. So here AB root 37 and BC root 37, CA is 2 units. Here two sides are equal. So therefore AB equal to BC. AB equal to BC. What is our conclusion? So therefore this is an isosceles triangle. The vertices A, B, C are the vertices of an isosceles triangle. So this is our conclusion. If the two sides are equal, then it is isosceles triangle. I think it is clear. Next question, show that the points 1, 7, 4, 2, minus 1, and minus 4, 4 are the vertices of a square. We have to prove these vertices are in a vertices of a square. So how to prove? What is the condition? So let the coordinates point A 1, 7 and B 4, 2, C minus 1, and D minus 4, 4. We have to show or prove that all the sides in a square, the main properties of the square, all the sides are equal and two diagonals are equal. If all the sides are equal, then the two diagonals are equal, that is a square. So we have to prove all the sides are equal. So how to prove? By applying the distance formula. So what is distance formula? D equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. First find the distance AB, then BC, then CD, at last DA. Next find the distance between the two diagonals, that is BD and AC. So first find the D. D means AB. So AB, the coordinates of the point A 1, 7, that is x1, y1, and the coordinates of the point B 4, 2, let us consider x2, y2. Now substitute the values. X2 minus x1 whole square, 4 minus 1 whole square plus y2. Y2 is 2 minus 7 whole square. So equal to square root of 4 minus 1. 4 minus 1 3 square plus 2 minus 7 5 square equal to square root of 3 square 9 plus minus 5 whole square, minus 5 into minus 5, 25. So equal to square root of 25 plus 9, that is 34 units. Square root of 34 units, that is AB. Next find BC. So BC equal to square root of, so here the coordinates of the point B 4, 2, and the coordinates of the point C minus 1, minus 1. First one x1, y1, and the second one x2, y2. Now substitute the values. So here x2 is minus 1 minus x1 is 4, their square, plus y2 value minus 1 minus y1 2 whole square. So equal to square root of minus 1 minus 4, that is minus 5. So minus 5 square plus minus 1 minus 2 minus 3 whole square equal to square root of minus 5 whole square 25 plus minus 3 whole square 9, which is equal to square root 25 plus 9, 34 units. So BC also square root of 34. Next to find CD. Distance CD square root of, so the coordinates of the point C minus 1, minus 1, x1, y1, and D minus 4, 4, that is x2, y2. Now compare the values of x1, x2, y1, y2. Substitute the values. X2 value minus 4 minus x1 value minus of 1 square plus y2 value 4 minus y1 value minus 1 whole square. So equal to square root of minus 4 minus of minus plus 1 whole square plus 4 minus into minus, that is plus 1 whole square. So equal to square root of minus 4 plus 1 minus 4 plus 1 minus 3 whole square plus 4 plus 1 5 square equal to minus 3 whole square 9 plus 25 equal to square root of 34 units. So this is also square root of 34 units. And next CD, then DA. So DA square root of, so the coordinates of the point D minus 4, 4. So this is x1, y1, and A coordinates of the point A 1, 7. This is x2, y2. Now substitute the values. X2 minus x1 whole square, 1 minus of minus 4 square plus y2 minus y1, 7 minus 4 whole square. Now simplify, equal to square root of 1 minus of minus plus 4 whole square plus 7 minus 4 3 square. So which is equal to 1 plus 4 5 square plus 3 square. So what is the answer? 5 square, the 25 plus 3 square 9, which is equal to square root of 34 units. So we conclude that all the sides are equal. So AB equal to BC equal to CD equal to DA. Next we have to prove these two diagonals also equal in a square. What is the main property of the square? all the sides are equal as well as the two diagonals also equal. Now next find the distance AC as well as the BD. First one, diagonal AC. Diagonal AC, square root of the coordinates of the point A 1, 7 and the coordinates of the point C -1, -1. So this is x1, y1 and next one x2, y2. Now substitute the values. X2 minus x1 whole square -1, -1 whole square plus y2 -1, -7 whole square. So which is equal to square root of -1, -1 -2 whole square plus -1, -7 -8 whole square. So equal to square root of -2 whole square, -2 into -2, that is 4 plus -8 whole square 64 equal to square root of 68 units. So this is the diagonal AC. Next find BD. Diagonal BD equal to square root of the coordinates of the point B 4, 2 and coordinates of point D -4, 4. So this one x1, y1 and next one x2, y2. Now substitute the values. x2 minus x1 -4 whole square plus y2 value 4 -2 whole square. So which is equal to -4 -8 whole square plus 2 square equal to square root of -8 whole square 64 plus 4 equal to square root of 68. We have to prove, so these vertices are the vertices of a square. So what is the condition? All the sides should be equal and two diagonals should be equal. So for our conclusion, therefore AB equal, all the sides AB equal to BC equal to CD equal to DA, all the sides are equal and the diagonals. So diagonals AC equal to BD, AC equal to BD, all the sides are equal and two diagonals are equal. Therefore our conclusion ABCD is a square. ABCD is a square. So I think it is clear. Okay, I will end up today's class. So we will continue in the next class. Thank you one and all.